644 is the year we started tapping into its power. We used it to move massive rocks to mill flour. 1,244 years later, we started using its power to produce electricity. And now, we power more than 30 million houses in the US alone just by using its power. Wind energy production is great, and new technology is pushing onshore wind farms to be more and more efficient and powerful. But can we make it any better? Or is greed just taking the best of us? In this video, we will discuss a few reasons why we should not use offshore wind farms to produce electricity. We will talk about how aquatic life, and not only, is greatly endangered by the use of offshore wind farms, and how, after decommissioning, there is no more that we can do with them other than burn them or bury them. For starters, let's talk about aquatic life. According to Degraer et al., there is a law we do not yet fully understand about how introduction of such massive hard surfaces will affect marine life. One thing we do know for sure is that with the installation of wind farms, soft sediment habitat will be lost. However, hard sediment habitat will increase. This is very likely to attract species that live on hard surfaces, such as blue mussels, anemones, sea urchins, etc. These species will then attract animals that do feed on them, and the spiral only gets larger and larger from here on. In theory, an increase in biodiversity is great. However, when you take into consideration that there is a good chance that non-indigenous species will find themselves in these new artificial reefs, that is when the problem starts. Non-indigenous species, especially those on the higher end of the food chain, will have a much higher chance of being uncontested in this new environment. That will eventually lead to them becoming an invasive species, leading to a great decrease in the population of indigenous species. And if any of those species are endangered, they're in great risk of going extinct. However, so far this is all an educated prediction of what might happen. Let's talk about something more concrete. Kelsey et al. Conducted a study on the collision, displacement, and population vulnerability of 81 marine bird species on the Pacific outer continental shelf. The vulnerability was presented as an index. The higher the index, the more vulnerable the species is to the factor that is being studied. If the population vulnerability index of a population is 0.5, 50% of that population will be affected by the effector. To fully understand these indexes, it would cost me a lot more time than I can afford to explain. Therefore, I have linked the paper on the description on this video down below. So if you're interested in understanding these concepts better, please do read that paper. Back to where we were. After the study was conducted, the results were shocking. In these graphs, the upper right quadrant shows a higher than 0.5 index for both measured variabilities. And as we can see, many species fall under the category. Pelicans, especially, have shown to be highly vulnerable to collision and population loss. Meanwhile, alcids have shown to be highly vulnerable to population displacement and population loss. However, what is even more concerning is the fact that the vast majority of species have a displacement vulnerability index of equal or more than 0.5, which, as I said previously, is extremely concerning, especially in regard to the diversity of that habitat. Out of all 81 species studies, none of them scored a vulnerability index of 0. All of them were affected by the wind farms built in that region. One other topic worth mentioning is where do these massive turbines go when they're decommissioned? I believe the best one to speak about this is Matt Farrell from Undecided with Matt Farrell, who made an excellent video about it.
But the same can't really be said for the blades, which are usually made from a composite material such as fiberglass or carbon fiber, depending on their age. These materials are strong enough to withstand the extreme weather conditions that the turbines are often subjected to, but light enough so the turbines can actually turn. But when they need to be decommissioned, there's little else you can do with them but to bury them in a landfill or burn them through a process called pyrolysis. The landfill option is obviously not very eco-friendly, especially when the blades can be longer than the wing of a Boeing 747 and weigh up to 8 tons each. This means that they have to be transported one at a time, and that's a lot of truck journeys. Plus, there's a lot of heavy machinery needed to cut up the blades before they're buried. With pyrolysis, the blades are chopped up, but then they're placed into high-temperature ovens to break down the composite fibers. This creates a material that can be used to make things such as paints and glues. But the process requires a lot of energy, so even though it can be thought of as a form of recycling, it's not all that green.
Even after we heard that, some might argue that due to wind speeds being a lot faster offshore, the efficiency of offshore farms will be higher compared to onshore wind farms. That is true, taking into account the fact that wind turbine efficiency does increase with the increase of wind speed. However, a mild increase in efficiency does not make up for the large amount of possible dangers these farms can cause to the population of both aquatic and marine life, and for the fact that as of right now, a significant portion of them cannot be safely recycled or appropriately disposed of. So this has been my video. I hope you guys enjoyed it, and you can find all the sources that I used and all the videos that I used in this video linked down in the description below. Enjoy your day.